Hey guys, it's Mr. Rysz. So we are on the second part of 1-6 here, so the last section. Um, this part is kind of a doozy, so we'll take our time with it. Remember guys, there's so many other resources that you can find to get some help with this. So we'll do what we can. There's not just one way to do this part. There's multiple different ways you can do this, but I'm gonna show you guys the way that I think works the best. So we're gonna solve now, how do we find a system of equation that works when we have three variables? Okay, so if I have a solution system here, which I have, okay, a bunch of x, y's, and z's in three different equations. Now the easiest way before was to graph. Well, unfortunately, we can't graph in 3 dimensions. So we got to find another way to solve this, and we're going to use elimination. Now I like to label my 3 functions a, b, and c so I don't get confused of what's going on, because the first step is really important. What our goal is to eliminate one of the variables. So if I'm looking at this here, I can see that A and B both very easily can eliminate the Z's. They're already stacked up together and the Z's are opposites. So I'm going to make a problem here that's A plus B. All right, so A plus B would be 2x plus y minus z equals -10. And then B here is -x plus 2y equals, or not equals, oh man, eraser. Come on. Plus z equals 3. All right, so that's already stacked up to eliminate the z's. So I'm going to add them together, and I'm going to get, let's see, 2x plus -x is just 1x. Y plus, oh yeah, I'm adding these together. Y plus 2y is 3y. The z's are eliminated. So again, -10 plus 3 equals -7. Okay. So then the next step is I need to pick another 2. So I need to pick either A or C or B and C, and I have to eliminate Z's as well. So if I eliminate the Z's from A and B, your next step is to pick another 2 combination and eliminate the same variable. So if I'm going to pick B and C. Actually, no, yeah, I'm pick B and C here. It's not the easiest one, but if I pick B and C here, what would I have to do? Well, B would be -x plus 2y plus z equals 3 equals, and then x plus 2y plus 3z equals 13. Now, this is perfectly set up to get rid of the x's. But since we got rid of the z's on this problem, we got to get rid of the z's on this one. So what would I have to multiply? I'd have to multiply this one by -3 here and get rid of that. And so let's see, -3 times -x would become a +3x. And then we'd have a -6y for the next part, and a -3z equals -9. And then I'm just going to leave the bottom alone. Okay, so we start adding these together, just like how we did yesterday. 3x plus x is 4x. -6y plus 2y is a -4y. Z's are eliminated. And then -9 plus 13 is what, 4? Wow, a lot of 4s on that one. Okay, so what we did here is we took 2 equations and we eliminated. Now we have these 2. Well, what we're going to do next is to take our 2 answers, stack them up together, and eliminate one of their variables. So x plus 3y equals -7. And then the other one is 4x plus 4y equals 4. Now I'm going to eliminate one of these. So if I'm working on this one here, so I always think of these are like puzzles or presents that are like wrapped inside of each other. I'm just peeling off one cover and getting to the next one. So if you have multiple varies, 4, 5, and 6, you just keep on doing the same steps. Okay, so here we go. This next one here. If I want to eliminate, I think the x's would be easier to get rid of. So I'm going to multiply the top by -4 times by -4 here. Let's see, this would be a -4x and a -12y equals, okay, a +28. And the bottom is just 4x plus 4y equals 4. All right, so now if I eliminate this here, x's go away. And let's see, y's would be negative 8y equals, add them together, 32. And now I can simply divide, and I figured out one key piece here, and that would be y would be negative 4. Okay, this is where it becomes nice, because now that we got one key piece, everything just starts unraveling. So, okay, now that we know y is negative 4, we can find x by plugging it back to any equation. I'm going to plug it back into this one here because x is kind of by itself. So x plus 3y, or 3 times negative 4, would equal negative 7. So x, let's see, minus 12 would equal negative 7. What would x have to equal? Add that over, that would be 5. So now we got x, now we got y, we got to find z. So now we're going to take both of those and plug it back into any equation to find z. I'll plug it back into this top one here. I'll plug it into the middle one. So going back up here, all right, x is 5, so we got negative 5 for x. Yeah, does that make sense here? 20 plus, yeah, negative 6, yeah. All right, x is negative 5, y is negative 4, so 2 times negative 4 plus z equals 3. Golly. All right, we get negative 5 minus 8 plus z equals 3. Let's see, if I add the 5 over and add the 8 over, or in other ways, add a 13 over, z would be 16. So our solution set here, we'll put everything in alphabetical order. X would be 5, y is negative 4, and z is 16. There's our answer that would work for all 3 of those. And we can plug them in to double check. All right, so I'm going to make another video of just going over more of these, but this is what we're going to do. So practice makes perfect, and so we'll keep going through these. One thing to watch out for, though, is that this doesn't always work out. So you can see this example here. There's no point of going through it and then surprise at the end it doesn't work out. But okay, they did the same thing here. They eliminated the y's in the first problem, made another problem and eliminated the y's in that one. And then what they did here is when you stack them up, everything goes away. Nothing works out right. So that happens here. You can see you can have 3 lines that never cross, and which is how it works out. Okay, so let's practice this one here. We got x plus y plus z equals 3, x minus y plus z equals 1, x plus y minus z equals 2. All right, so A, B's, and C's. I'll start drawing here. All right, so it doesn't matter which one you do. I kind of look here and go, okay, I just add A and B together. I'm going to get rid of the y, so x plus y plus z equals 3. X minus y plus z equals 1. If I just add these together, all right, I'm going to get rid of the y's, and we get x plus z. Oh, no, we don't. Whoa. Good morning, Rysz. Somebody yell at me yet? Add them together. X plus x is 2x. Y plus negative y goes away. Z plus z is 2z. 3 plus 1 is 4. There we go. There's the equation. All right, next what we need to do is add another 2 together. Our goal is to get rid of. We can't do A and B, so we can do either A and C or B and C. I'm going to stick with B and C because look at that. They both eliminate the y. So we get x minus y plus z equals 1. X plus y minus z equals 2. All right, our goal is to eliminate the y's. Well, let's do this. X plus x is 2x. All right, y, negative y plus y goes away. Z, oh, whoa, what happens here? The z's, x's, and z's cancel out here. And we just get 2x equals 3. That can happen sometimes. Sometimes you can get really lucky and you can find an equation that eliminates both the variables. What that means is, like, if we have a present, what happens is you unravel 2 pieces at the same time and we get a key piece. So right off the bat, we know that x is divide, we can say 1.5 or 3 over 2. And we can use that to find other things. Now that we got that, it wasn't a waste of time that we figured out what z is or got this equation, because I can plug that in. 2 times 1.5 plus 2z would equal 4. So do a little math here. That's 3 plus 2z equals 4. 2z would equal 1 when we subtract, so z is equal to a half or 0.5. All righty, so then we just need to figure out, okay, what's y, and we can plug it into anything. I'll plug it into the beginning. All right, x is 1.5, y we don't know, and z is 0.5, and then it equals 3. So add them together, that would be 2. Subtract it over, be 1. So the answer here in order, x is 1.5, y is 1, and z is 0.5 or 1/2. There we go. That would work for all of them. Alrighty, clear electronics. Okay, remember anytime in this video, guys, if you want to go back and try to do that problem on your own, pause the video and do that. Or this problem here, pause it and see if you guys can do it. This is going to be the last one we do together. So if you guys can handle this one on your own, you are off to a great start. All right. So to get it started, A, B, and C, we're going to go through and see, can we eliminate any variable nicely? The only thing I see right off the bat is that A and C both eliminate Y. So I'm going to add A and C together. This is not the only way to solve the problem, but I kind of look for the easiest method first. So 2x plus y minus 2z equals 3. And then we got 3x minus y plus 5z equals 10. So don't need to do any changes there. Sometimes you do. Sometimes you got to make changes on both of them for every problem. It just sucks that way, but that's what happens. Add them together. 2x plus 3x is 5x. Y plus negative y goes away. Negative 2z plus 5z is a 3z's. 3 plus 10 is 13. Okay, next what we need to do is get two different ones. So now we can't use A and C. We can do B and C, or we can do A and B. And we got to get rid of a y. I'm going to do A and B here, just so I can keep organized here. So I got 2x plus y minus 2z equals 3 for A, and then B is x minus 2y plus 7z. Oof, that was a terrible looking 7. Try again. 7z equals 12. All right, we got to get rid of the y. So in order to get rid of the y's, if I multiply the top by 2, the y's would be opposites. So I got 4x plus 2y, and then minus 4z equals 6. And at the bottom is just x minus 2y plus 7z equals 12. Okay, so add them up together. They are opposite now with the y's. We got 5x's, and then over here we got 3z, and then equals, add them up together, 18. Oh man, what's gonna happen here? Now when we stack these up together, you guys can probably already see a mistake. First one, I got 5x plus 3z equals 13. The other one, I got 5x plus 3z. I'm just double checking that these are pluses. Yep. Equals 18. Now you can see if we eliminate them, they go away. We get 0 equals negative 5. So this one is a no solution. Okay. So hopefully you guys see what happens here. Let's check the CYUs, see if you guys have any problems with those, and maybe do another one. All right, let's see. Oops, gotta use my mouse. All right, so you guys got CYU2 of the 1.6 section to do. Let's preview that. Let's big screen it. All right, so system of equation like before, that's an easy one. Stack it up and eliminate. All right, which one to do? Which one to do? Let's do the last one. Let's go for the gold here. All right, I will try to write small. Once again, try your best here. Maybe I'll get the first variable and I'll just kind of pause it there. All right, so if I was going to look at these ones here, what looks good? Well, maybe I'll get rid of the z's here, because all I need to do here on this first one If I multiply this top row by -1 and leave the bottom row alone, we'll get rid of the z. So if I multiply the top row by -1, I get -4x plus 2y plus z equals -5. I'll leave the middle row alone. X plus 4y and then minus z equals -1. So I can add these together and we get -3x. And then here we got, see, 6y. The z's go away and we get -6. Okay. Next thing, let's get rid of the z's and get the other one. Now to get rid of the z's on this one, I'm going to multiply the middle row by -2. I'm going to leave the bottom row alone. So middle row times -2, we'd get a -2x minus 8y plus 2z equals a +2. And I'll leave the bottom row alone. Remember, the goal is to get rid of the same variable that we got rid of in the last problem. So this way the z's cancel each other out. Add them up. Ooh, lucky us here. X's and X's cancel out here. So we get -8x plus, so that's a -10y. And then we get here, these cancel out and we get 0. Wow. We already got one variable by itself. Y is equal to 0. I'm going to stop there. Hopefully you guys know what to do next. You can plug it back in to find the other two. So if you guys ever need help, just reach out, ask me some questions, email me, see me in class or on the Zoom sessions on Monday. Best of luck with this, and we'll see you guys next time. Have a good one.